right now in the meeting and later on. My name is Ramansh Sharma. I am currently a machine learning engineer at Omdena and an AI for Good organization. I am also a sophomore at SRM Institute of Science and Technology in my undergraduate in India. I was a part of the class of 2019 at Bronx Science, and unfortunately, like in the middle of senior year, I had to come back to India. So I didn't technically graduate. I'm not technically an alumni, but I was there until like the middle of my senior year. So let's get started, okay? So I want to first, so I'll be talking about a lot of things today, and if at any point my voice is not clear, just let me know. So I'll be talking about a lot of things. So I want to get started with some advice on how to get started in machine learning. Some things you can look out for and some things you should focus on as you get started yourself. So this is more for a beginner oriented advice. So the first advice that I always give to people starting is start simple. As much as neural networks are interesting, don't go jumping directly into them. They are really hard to make, really hard to train, and really hard to implement. You should definitely approach and plan yourself to go and learn them. But that shouldn't be what you start with. I've seen a lot of people start learning machine learning with neural networks, and they often jump back and forth between big algorithms and small algorithms and don't really understand how it all fits together in a linear way. And that understanding is important to have. So start simple, predict house prices, use some small data sets, and use random forest classifiers or LGBM classifiers, because those are easier to understand and faster to train and more interpretable than neural networks sometimes. When you start learning, this goes without saying, but I've seen some people that go for paid boot camps, especially in India for some reason. But you don't need paid boot camps at all. I've been in this field for almost 2 years now, and I've never paid a dime to learn. I use free resources, and the fact is that free resources are much better than paid resources. Go to Coursera. Coursera actually has the best educational content, at least in terms of machine learning, that I have seen so far. I started where most people start, which is the Stanford University machine learning course. It's hard. It's a good course because it teaches you all the algorithms, core machine learning from scratch, and you don't have any high-level libraries to split your training or testing data set or shuffle your data set. You do it all from scratch and in MATLAB. So there's no list comprehensions like there are in Python, so you can't use any shortcuts, and you really have to understand every single line of code inside out to get it to work. And even if you might not like coding in MATLAB, it does become a lot useful later on. And deep learning, and I'm going to talk about this more later on too, but there are other resources from companies like Deep Learning AI, also on Coursera, that are a continuation of ML courses from Stanford, and they're really good as well. And I continued with them, like the deep learning specialization and other things. The good thing about them is that they don't skip the basics of linear algebra or calculus. They give you what you need to know, especially when you're coding your algorithms and you need to understand what's going on behind the scenes, sometimes when you're debugging. But you should not skip them in any case, because whatever you might do later on when you become a professional in the field, whether you're a researcher or a practitioner, knowing basic mathematics is tremendously helpful, and it will not only save you a lot of time, but make you a good machine learning practitioner. So, and another important thing is that don't just watch the online courses or any learning material or any workshop. Try coding alongside them if there is a coding material. When you've learned enough, you'll make a project out of it, like modify it. And I'll talk about that too, how you can make your personal projects for your profile, and in a good way that appeals, that interests other people and shows that you understand what you did in that project. So Some time ago, I attended this really interesting workshop from Dr. Utku Kose. He is a very famous Turkish researcher in machine learning. And some of the things that he said really were really helpful. So I thought of sharing them here too. So you should not, so some of these things are not as cool as directly jumping into algorithms, but they give you a broader perspective that when you're conversing with another person, with your colleagues or with a recruiter, or some friends even, it becomes very helpful to know about these things. The philosophy of AI, how it came about to be. Why? So always ask yourself, if I was in the shoes of the founders of machine learning 30 years ago, what would I have done? Like, how do I get the perspective of the researcher that invented a famous algorithm? Don't just understand the algorithm, but understand the motivation behind it. Why was it required? What did it change? How did it become better than previous models, and so forth? You should, of course, don't learn libraries directly, TensorFlow or PyTorch or JAX or any of them. Start simple. When you get to Python, you can code everything in Python out first. You'll need mathematics, as I said, and you'll learn about data science and statistics. There's a lot of fields in this field, like AI, machine learning, data science, decision science, that are really, really overlap, and there's no fine boundary between them. You just decide. You come to know what you're actually working on once you're in a professional position. You should always try to join events because you get to learn from the communities, and I'll talk about this more later too. And what's really useful is that read publications about AI, read research papers and articles about those research papers, explaining them. I'll talk about some really cool ones, but this is really important. Don't just code. Never just code or work on a problem. Always talk to other people and learn from what other people have written about it. Writing is really important in machine learning because you can explain to other people of a really complex idea or concept in a fundamental way. So before I go to some good publications that you can learn from, I wanted to show you this. So always take handwritten notes. This is an example. So this diary is my diary, which I've started from May 2019, when I've started learning machine learning. And I have written all the important things that I feel are important when I was learning with the online courses. When you take handwritten notes, it increases your retention rate of the material. And in ML, it's much more important because you're not just reading something or coding something, but you're understanding a concept and the math behind it. But in order to connect the math to the concept, it's better if you write it in a way that you understand it. The instructor on the course or a speaker in a workshop might be explaining it in a way that they think is helpful to most people. But in order to personalize it to yourself, it's better if you take handwritten notes. And believe me, it becomes really helpful when you need to look back on something and you want a specific equation or a formula, and you have a diary or a notebook that you can just flip through. It's really useful. So coming to some publications that I think are really useful. My favorite one is The Batch. If you don't know about this, The Batch is a weekly newsletter that Deep Learning AI publishes. They send it to your email, and it has everything that you need to know of the most important advancements in machine learning in the past week. It goes from the latest transformer models. I think there's more transformer models than any other models out there. So it talks about the latest models and what it means and how companies are using them. The batch talks about not just the models, but also how they were made. What are their pros and cons, why people should consider using them, and what problems did the researchers face, and what the people who are writing the batch, are thinking, their opinion on it. So they also include that, which is always helpful because sometimes they call out some algorithms that are unfair. For example, some algorithms are misused sometimes by the police or by some other organizations. So they talk about that how can we as machine learning practitioners take steps to prevent that from happening. And every single issue of the batch has an excerpt from Dr. Andrew Ng right at the top, that where he talks about what he believes is important about a broad topic in machine learning, and it's always insightful. Excuse me, to read about that. Another one that I really like, and this is more recent, it's newer, is Alpha Signal. Alpha Signal is super cool, and what Alpha Signal does is that it curates all the machine learning papers and publications out there using AI. So it's doing AI on AI, and it gives you the papers that you find interesting. So you can within your email, you can change your preferences, and it's basically going to curate the top publications for your choice. So as you can see, it says 5 out of 1,060. I don't believe it's 1,060 of my preferences, but it's 1,060 of the top publications that Alpha Signal sends per week. So it's really useful, and it also gives you the latest tweets. So Twitter's the most upfront platform about machine learning, where researchers share their news first on Twitter and probably next anywhere else. So Alpha Signal is super useful to read the latest papers. Definitely check it out. So I'm talking about these things. I'm going to get to machine learning careers too in the later part of the presentation. But first, I want to talk about how you can become a machine learning practitioner and then become good enough to apply to certain places. Okay. So now I'm going to talk about a couple of interesting projects that I have worked on or I am currently working on. The first one is my favorite one that I'm going to talk about today, which is predicting illegal dump sites. So last year when I joined Omdena, I joined this project that was in partnership with the Trash Out NGO in Europe, where Omdena brought together 35 data scientists from around the world to solve the problem of illegal dumping. Not really like solve the problem permanently, but sort of make something that can take steps towards preventing illegal dumping as much as possible. So let's get into it. So first of all, we needed data sets. So what Trash Out provided us with was around 50,000 points of dump site. They had a lot of features for each dump site, like continent, the latitude and longitude, and the size of the dump site, and some other features too, like what kind of waste was it? Was it biological waste, or hazardous waste, or other kinds of waste as well? So we had that kind of information. But what we wanted to do was create a machine learning model that could predict a new illegal dump site before it happens. So sort of given certain features, our model would spit out a binary classification number where it would tell us the likelihood of a given location becoming an illegal dump site based on a lot of numerical and categorical features. So we needed to come up with those features. So we started looking at places we can get those features from. So those places, for example, were OpenStreetMaps. OpenStreetMaps, it gives you the geospatial data in the sense that it gives you the distance to, for example, the nearest road, which turns out was really important. So we got the distance to nearest road and distance to the nearest highway, so big roads and small roads. So we needed that from a given location. OpenStreetMaps API can give that to us. Then we needed population density, because we figured out, so when we were brainstorming, okay, I don't know. Wait, hold up. Okay, I don't know if. So when we were brainstorming about features, we were thinking, what affects a location to become an illegal dump site or not? So we said population was one of them, and so was population density. And I'll talk about population density in a moment, but basically it's so CDAC data set gave us the a real value population for every single 1 kilometer squared cell on the entire face of the planet. So that was a lot of data, and we needed to come up with a good way to, of course, parse through it. But that was not enough. What we also needed to do was come up with population sort of gradient. Yeah, I was saying density earlier. Density is the normal one. We calculated a gradient. The gradient was that, let's say you have a dump site in a 1 kilometer squared cell. That's not enough. The population of that 1 kilometer squared cell is not enough for the model to really see if that's affecting that place to become a dump site, because realistically speaking, the population densities of the area around that 1 kilometer squared cell also affects it. So we sort of took a weighted gradient of the 8 other 1 kilometer squared cells around the center cell. And then we made a population gradient out of that. And turns out that was useful. We also needed information about venue categories. So certain venue categories like gyms or restaurants or public parks are more likely to have a dump site near them than are other quieter places, right? So Foursquare API gave us information about that stuff. We also needed socioeconomic indicator, not just for the machine learning model, but about other tasks as well. The thing I'm explaining right now is one task of the whole project. There was another task in the project which worked on classifying a given image of a trash into the type of trash it is, a scalable solution. And there was another one that was working on the knowledge base that TrashOut was maintaining of different dump sites. So that was those were the kind of data, those were the data sets that we worked with. These are some of the features that we came up with: the 5 most frequent venue categories, the closest venue categories, average distance to venues, the number of venues, and there are a couple of others as well. But that was not enough. What we also needed to do, and I'll talk about that in a second, I guess. So here, yeah, we needed to understand the data too. So the project was 2 months. The duration of the project was 2 months. And what we did for the first month was analyze our data set as much as we can. So what I just described in the past 5 minutes happened over weeks, because we needed to understand what can cause dump sites. So I'm trying to take you through the perspective and the steps we took to understand, to like sort of connect the dots backward. So we needed to understand, was there a correlation of the size of the dump sites, or was it just randomly distributed? Turns out we didn't work with the size of dump site. It could be an theoretical extension of the project to also predict that the size of the dump site. But for the purpose of our data set, this is just for Bratislava, the sample city we were working with, but it was randomly distributed, so it didn't make sense to it. But in order to teach the machine learning model what a dump site is, we also need to teach it to understand what it's not. So what's a non-dump site? So then came an interesting turn in the project. So we needed to make our control data set. So what we decided to do eventually, when we were brainstorming what a non-dump site is that what we decided was that the non-dump site we pick, we cannot pick any non-dump site, because that won't help a machine learning model learn meaningful differences between the two classes, dump sites and non-dump site. We couldn't just say that for 50,000 dump sites, there's only one non-dump site, and it's for all of them. But that wouldn't have meaningful differences in the features we just talked about: the population density, population gradient, the distance to roads, and those features. So what we decided to do was that from a given dump site, we decided to pick a random point, a given radius away. And the best radius, we experimented with the radius too, and the best radius turned out to be 1 kilometer. So we just tested 500 meters, 1 kilometer, 1.5 kilometer. 1 kilometer made the most sense. So we pick a random point on the circumference of the circle from a given dump site 1 kilometer away. And we also need to take into account the fact that this part of the circle could lie in a water body. So we needed to find out, using some of the APIs that we were working with, if it lies in a water body. If it is, then we don't pick there. Then what we did was that, what if there's a cluster of dump sites here? So if it's a cluster of dump sites, we find out the sort of the centroid of that cluster. And from that centroid, do we find the random point of the non-dump site that would be associated with all of those dump sites. So the points are, so the dump sites and the non-dump sites are close enough. So there are subtle changes in the numerical and categorical features of the model, so that it learns to map and like classify those two different classes. They're not so close that the model, can't learn the key differences between the features. So we experimented a lot with that, and we finally came with the radius of 1 kilometer. So once we trained a lot of models, and what we did was that we experimented with 3 types of models. First, we started with random forest classifiers. but they were not able to fit the data well. So we turned to neural networks, and we excuse me, and we spent a lot of time trying to tune our neural networks on the data set, but the test accuracy was not good. So despite doing everything we could in that given time span, for some reason the test accuracy was not being good, and we needed this model to go into production. So what we did eventually was use a light gradient boosted model, an LGBM model, to basically classify between a dump site and a non-dump site. And eventually, I believe our final test accuracy was 88%, which is good for this novel kind of model. I don't believe that there is any other model, productionized model, anywhere in the world that projects illegal dump sites of a given location. So I think it was 80%. Okay, I'm also like reading my the blog I wrote right now. So so what you're seeing on the screen right now is a Shapley plot. What we needed to know and what we needed to describe to trash out what was not just a model that we made and handed over to them, but we needed to tell them, what features turned out to be really important. And it turned out the distance to road was the most important feature that we could have looked at, because it changed the accuracy of the model the most when the distance road was removed. And that's how we know whether a feature is more important or not, or we tune it, not just remove it, we change it, we randomize it. So we did a lot. We did a lot of data analysis, and we came up with the Shapley plot in the end that turned out to be useful to trash out. And what our final product sort of looked at for this task was we created a heat map. So this is the heat map for Bratislava. What our heat map does is that the regions in a city or a place that are more likely to become a dump site, an illegal dump site, are highlighted more in red than yellow. And this turned out to be really useful, because what TrashOut can do now is notify, municipalities and government agencies and other the cleaning crews in cities around the world or anywhere, that which regions, which neighborhoods are more likely to be affected and to become an illegal dump site in that place. So you can see like the sort of roadmap we took. So and if you have any questions later on, I'm happy to answer them. But I'm not pacing myself well, so I'll just move on. So that was a good project. And now, so a couple of personal projects. So last year in February, I think, when I was learning, RNNs. Sorry, not RNNs. When I was just learning deep learning in general, I tried to make a flight price estimator, and I trained on about 9 million flights. That was the largest data set that I worked with at that point of time. And I was working with a lot of numerical and categorical features, and I tried to fit this large neural network to estimate the price of a flight. And whatever I did, it didn't turn out really well, because my accuracy was super bad. Because this is not a classification algorithm, but a regression algorithm. And that's why what I did was that I made an epsilon. So if the estimated price is between the range plus minus $70, it's okay. And even with a high, and that was a bad epsilon, because the range of flight prices lasted from $200 to $400 or $500, and $70 is a big ratio compared to those prices. And even then, the accuracy was super bad. In retrospect, now what I believe I could have done better was use not a neural network, but another kind of a smaller model, because smaller models sometimes fit better. Not to say that neural networks don't fit better, they do, but they're harder to tune, and it takes more time to figure it out. So that was about that. When I was first learning recurrent neural networks, I was interested in trying to see what I could do with it. So what I did was that I made an algorithm, a bot called alternate reality, where it would write something in my style. So I didn't really write a lot of stuff in college. So I was like, what if I give it poems and research papers and essays and homework that I've written at high school, and feed it to it, and what would it give out? Like, would write it in my style. So this, when it spewed out a character level recurrent neural network. So basically all of these characters, I just gave it like, my name is Ramansh Sharma, and then it spewed out character by character and pieced it together. So as you can see, it wasn't always that good. And this is the first one that it actually gave me. but that spelling is super bad. And since there was a really large history paper that I fed in it, I got a lot of historical, terminologies in my output. So it's sort of like garbage in, garbage out. Your data set matters a lot. So, but you can see like not everything is bad. It did learn some punctuation techniques and capitalization, even though even though there's not a lot of spelling accuracy. Some placement of word do make sense. Like could have been. That positioning of words do make sense considering its character level. In my opinion, like character level are more interesting because they have to learn they have to learn more than word level RNNs, so it's more interesting in my opinion. But this was a project that I worked on. So before I move on to the next part, I'm working on other projects too that I couldn't really put into the presentation. But for example, like right now I'm working with the World Resources Institute within Omdena, and I'm working with GPT-3. For GPT-3 is being used for text summarization, and I'm working with NLP and policy analysis. So that's another cool project that I'm working on. Unfortunately, I can't really put any details of the project into the presentation, but I just wanted to mention that. So you work on a lot, you get to work on a lot of cool projects once you spend some time in the field, basically. So how to work on personal projects? Let me just like move through this a bit faster. Form a preliminary plan, at least in your mind. When you work on something, you'll know what you want to work on. For example, if I'm interested in aviation, I'll find an aviation data set somewhere. Kaggle's the best place, to be honest, to find publicly available data sets. And there are other like university places too that have a lot of open source data sets. So if you don't have the data set, you'll find it online. And if you already have it for some reason, begin cleaning it and analyzing it. You'll spend for any project you're working on, if it's interesting at all, you'll spend at least a week and a half at the very minimum cleaning and analyzing it and visualizing it. You always visualize. There's no machine learning without visualization. Use Matplotlib or Plotly or SciPy or any of the other libraries. Use Seaborn to visualize some kind of correlation between the features, clean it up a bit, see what happens if you drop some features. Do you get better patterns that you can see on a 2D or 3D plot? Do you even need machine learning for your problem? Always ask yourself that. Don't try to force ML into everything that you see. Simple models are better than neural networks. Start with them. I'm not saying don't work with neural networks, but if linear regression and random forest classifiers do good, analyze them and document them, and then move on to neural networks if you think it can increase your performance. If you get 98% accuracy, test accuracy with linear regression, you should not use a neural network because it doesn't make sense. For 2% accuracy, you try a bigger model. Visualize your model's performance, track your training and validation accuracies, and see if you're overfitting, if there are some other random weird things happening with your training process. What can you do to make it better? Always ask yourself that question. Once you have a good model, write a user script to let others make use of it. I've always made it a practice to always write some kind of a helper module Python file that others can use to run and document it well. Always document it well. If your model is really novel, write a Python package for it. Put it for free on PyPy and make it available for other people to download from. I've seen I've seen a lot of people make really cool projects and then make it available as a package, and that really shows you understand your material really well. If it's not novel, you can still host it for free on a hosting service. Either use Heroku, which is the fastest to set up with. You can deploy a model on Heroku in less than 10 minutes for free, of course, or use AWS. You can get free credits on AWS and make it more customizable and stronger. Always document your project, no matter how small or how big it is. Learn how to write in Markdown and make a good documentation of it. Give some example plots, your motivation for the project, some results, and talk about the steps someone needs to replicate your results and how they can, excuse me, and what pieces of code they can run to run your model. So you have all the necessary tools available for free to make state-of-the-art advancements and discoveries in machine learning, not just make personal projects. For your compute resources, Colab is more than enough. For my project right now, WRI, I'm using Colab right now and it's working just fine for me. I'm working with a huge model and Colab is working just fine for me, not even Colab Pro. If you want to collaborate with others and you're saying, it's hard to collaborate with Jupyter notebooks and machine learning models, use DeepNote. DeepNote is awesome. And there's also new places like Daxa coming up where you can collaborate with others real time on machine learning notebooks. For data sets, you can find Kaggle. Kaggle also has good compute resources. So you can see whichever one you prefer. But for Kaggle, I usually prefer it for just data sets. And there's weights and biases. So when I was working last year, weights and biases weren't that big, but they're pretty big now. Weights and biases is super helpful for tracking your models. And once you train a lot of model, instead of storing them in your Google Drive, it becomes, if you can spend some time learning weights and biases, it becomes really useful with weights and biases. And to learn other things, learn new things, you're going to want to read research papers, no matter what you do in the industry or what you're doing. If you're in research, you'll want to read papers anyway. Archive Sanity is the best place to read machine learning papers. I don't use it that often because I just stumble upon papers I want to read somehow. But Archive Sanity is really good, actually. Dr. Karpathy has did an amazing job making it. So make use of it. Definitely check this out. Okay, so applying for internships and jobs, but how do you do that? Okay, so make a habit of keeping your LinkedIn profile up to date. This will help you, talk and write about your experiences in a professional manner. It's always, LinkedIn is the best place for computer science, not just machine learning. So make a profile right now, like before the end of the workshop, if you haven't done it already. The only way to become good at applications is to apply a lot. Turn on, internship alerts on LinkedIn, like machine learning internships or researcher. And it doesn't matter that, you don't think you're qualified for that position. I used to apply to any place I could apply to that had the words machine learning in it. It's not the best practice, but it doesn't matter because the only decision that I'm going to get is going to be in my personal inbox. So it doesn't matter. I used to apply to 7 or 8 positions every single day, and I applied to more than 100 before I got into Omdena. So all my freshman year, I just kept applying to places. I applied to places like senior data scientist at Uber, which I knew I was not going to get in, at least at that time. And I still applied because it was so what did I gain from applying? Well, once in a million shot. But more importantly, I learned how to write my answers, sort of technically describe why am I proficient at what I do? Why am I good at communication the way I communicate with other people? How do I make myself useful to this company that I'm applying to through my skills and my experience? Reach out to recruiters over LinkedIn. This is the easiest thing you can do. Out of 8 to 10 cold messages that you send out, you'll receive at least one reply, and you should definitely send out more than 8 to 10, just eight to 10 messages. Keep your pitch short. I've seen a lot of people write a lot. I used to do that too. It's okay. Keep it short. You sometimes feel that if you don't write enough, the person won't like it. They'll be like, you're not putting in enough effort into even asking for something from the recruiter or from a person at a company that could refer you. I don't know what's happening, but keep it short. 5 lines is more than enough. Just tell them you're interested in something and you'd really appreciate it if they could, connect you to someone or refer you or do any of the 100 other things that people can help out to you on LinkedIn. When I first started, and I'll talk about this in a moment, but I met a lot of people on LinkedIn that became really close friends and colleagues to this day, and we still collaborate on so many different things. These are just some other things that I wanted to talk about. But always be prepared to talk about your past projects is really important because recruiters love asking you what you've already done. They might even open up your GitHub and ask you on a random project, why did you use this specific thing at this specific time? Why did it make sense to you? And be comfortable answering them. It doesn't have to be a perfect answer. They just want to see your thinking process at that time. And another useful way to get started in the AI industry is joining machine learning communities. Machine learning is not just a desk job. It's a community thing. You have to talk to other people and collaborate with other people. And these communities can help you get started with resources, projects, and internships. The best one that I find is deep learning AI. And what I mean by deep learning AI is that if you know about deep learning AI specializations, you might be interested in knowing that they have free Slack workspaces that you can join, where you have all the learners on that specialization around the world that have joined that Slack workspace communicating with each other. When I started the NLP specialization from deep learning AI on Coursera, I decided to give it a try. And when I did, I saw there were so many people, literally hundreds of people asking questions and people from deep learning AI answering them, technical questions about something's wrong with the grader, please fix it, and other things as well. More importantly, if you're interested in m- like finding more things, these workspaces can connect you to people looking to hire, looking to give you an internship, or like simply collaborate with you on a project. Don't always just aim for companies and an acceptance letter. Just collaborate with other people, and eventually you're going to move in the right direction that you need to move in. You can find other people that are like-minded and want to work on a similar data set, pick it up, start collaborating on DeepNote. It's perfect, right? Okay, another community that is really special, Pioneer. Pioneer is also under deep learning AI, where you can become a deep learning AI ambassador and host Pi and AI chapters. I myself host a chapter in Chennai, the city I'm in right now. There are a lot of chapters around the world, more than 50 countries, I believe it is. And these chapters host the best events that I've seen so far in machine learning. Conversations with experts and industry leaders, discussions around the best practices, and so many other things. And you can even collaborate on Pioneer chapters with premier conferences, premier ML conferences around the world. For example, NeurIPS. NeurIPS is neural information. I think neural information processing systems. It's the premier NLP conference. Happens annually in Canada. This year they started virtually. Last year, in 2020, they started virtually, and they had a lot of local meetups, virtually speaking. So what one of my friends that I met on LinkedIn initially, like more than a year in 2019, actually, we decided to host a meetup together, and this was our guest speaker. These were guest speakers. Just look at their profiles. We had candidates from PhD candidate at Stanford, AI resident at Facebook, AI engineers at Facebook, and so many amazing people just talking about their professional experiences in machine learning, in production, in research, how to get started in machine learning, and just so many varied topics. If you just search Pioneer Nairobi, you'll find this YouTube. You'll find the live stream YouTube that happened in December 2020, and definitely check it out. And this was our guest speaker, like a keynote speaker, Arno Pretorius. He is the only African researcher to have 2 papers accepted at NeurIPS in 2020, and it was just amazing to listen to him at that time. We also had an amazing Women Shaping the Future of AI workshop, where they talked about how sometimes to fill the gender gap in our field, how can you encourage more women to take up the career in machine learning? How can you encourage them to get started? And also talking about a lot of initiatives that organizations like Women in Machine Learning and Data Science, that's an organization, have taken to incorporate some of these things. So we had an amazing Women Shaping the Future of AI workshop in our NeurIPS meetup. So there's so many communities that you can be a part of. There's another one. This community is maintained by Abhishek Thakur. For those of you who don't know him, he is the world's first and I think only 4 times Kaggle Grandmaster, and he maintains this. This place actually, Data Muni is super cool. They have, I think, more than 7,000 people in the Slack. And I think they're trying to move to Discord because Slack can't handle anymore that many people. So it's super cool because you can write with Data Muni. So Data Muni has a website, and what you can do is that you can write an article with them and check out some of these articles that they've already written. Super technical and super insightful in the best practices to use with complex algorithms. And just if you open any one of them, you'll see what I'm talking about. So check them out over there. Okay, so and there's some. Okay, so once you're in the communities, how can you get started? Where to apply, right? So I'm going to talk about a couple of places that I think are good places to get started with, and put your effort in, because you can definitely be here, be accepted here if you put in the effort and if you're serious about it, if you're hardworking. So first is Comma AI. This is probably one of the hardest to get into that I'm going to talk about, because but it's open source. So these are some. So I talked about a lot of companies and organizations, don't talk, and some projects that I couldn't talk about. So for Comma AI, it's not like that. Comma AI is open source. They have it's a self-driving technology company, and and it's super cool because in order to be considered for an internship at Comma AI, before sending an application, or even before your application is considered, they look at the pull request you made to their GitHub repository. It's super cool because before looking at your resume, they want to see what you have done for open source communities. People sometimes think that machine learning cannot be open source except just models and pre-trained ways, but there are entire companies that have everything that they do open source on GitHub, and Comma AI is one of them. And the only challenge you have to do on their GitHub, honestly, is predict. I think they give you some video files of that their self-driving cars sometimes record, and you have to do some kind of a classification problem. I'm not entirely sure, but check out Comma AI. Next is Google Summer of Code. Google Summer of Code is really interesting and really useful. I'm not sure they they take high school students, but right out of high school, you should definitely consider applying to Google Summer of Code. Google Summer of Code Google basically partners with a lot of open source organizations, or even like closed source organizations that want to do open source projects with students around the world, literally. And their projects are really interesting because of the variety that they have in them. You can work on web development, game development, you can work in Unity and C Sharp, you can work, and recently I found out that they even have a lot of machine learning organizations, or at least open source projects that are available. So, and it's, excuse me, it's a 3-month project that happens at Google Summer of Code. And I just want to highlight some of the organizations that I found interesting that you can contribute to. They don't always have to be organizations. They can be an open source project that have, that are interested in partnering with Google Summer of Code. You can literally contribute your project at GSOC, as it's called, can literally contribute to the R programming language and the packaging that R has. You can contribute to Linux Foundation and VLC Media Player and other organizations like that. Other ones that I really found interesting, especially, are TensorFlow. Think about it. You can literally, your project at GSOC can literally change how TensorFlow works. And that is just so cool to think about, that you can directly contribute to one of the most famous and popularly used machine learning frameworks. To be honest, I used to code a lot in TensorFlow. I started with PyTorch, and I don't think I'm going to go back to TensorFlow unless I have to for one project. PyTorch just seems better. And if there's PyTorch, I might consider applying. And you can apply throughout college. So you have time. You have time. Anyone who's listening to this workshop right now, you have time to apply. And it's interesting how you apply to GSOC. And I just want to show some other organizations too. Of course, Python will be there. There's no way Python wouldn't be there. And you can apply to Postman. Postman is growing. Postman is a pretty good organization, not just for GSOC, but to actually work at. And just think about some of these things. Other cool organizations are OpenMind and OpenCV. I'm talking about machine learning projects that in GSOC. And if you'd been paying attention, look what we found here. OpenStreetMap, the API we were talking about earlier. Actually, OpenStreetMap would be really interesting. Think about how you can use some technology, not just ML, but A-star algorithm or some other graph related problems to improve OpenStreetMap's API. You can think about that. And the application to GSOC is really interesting because before being accepted, you have to talk to the people who are representing these organizations, and you have to say, give your complete plan and even show a proof of concept of some of the things you'll be doing during the project itself. And if you go to the website, you'll see more what I'm talking about. But GSOC is something you should definitely look at. There's also MLH Fellowship. And I'm pretty sure MLH Fellowship also accepts high school students. So you should definitely check this out. It's hard to get into MLH Fellowship, but it's really cool. And some of the projects that I've seen coming out of the fellowship program are super cool. They work with a lot of transformer models and make sort of this autoregressive new library that they published, and they made it as an API with what is it called again? I think it's called, Fast API. So, so sorry. So MLH Fellowship is another cool thing to look at. So there's also a lot of other, I wanted to briefly talk about Omdena because you could really benefit from applying to Omdena. So I'm not a recruiter of Omdena, but the reason I want you to consider applying to Omdena is because it doesn't matter if you're a high school student, or if you're a college student, or if you've been in the industry for 50 years. We have some people that are really experienced in the community. Because I think one of our like youngest collaborators is 17 years old when he joined Omdena. So at Omdena we've partnered with, in the past we've partnered with NASA, WRI, Crash Out, the Red Cross Foundation, worked on projects for the aftermath management of earthquakes, and working with satellite imagery, working with images from Mars. And there were projects. We have legendary projects in which we have evaluated 700,000 PDFs in 14 hours for a project on road safety in India. There's also damage assessment of desert locusts, child and sexual abuse in developing and third world countries, climate change, and climate hazards, predicting wildfires, disaster response, malaria prevention, and one of our best projects that was super impactful was rooftop solar panel detection, in which we were based on satellite imagery from, I think, Google API, Google Earth API. We were able to give you the energy your house or your building would be able to produce if you utilized solar panels. And it was so cool because there are sometimes obstacles on the roof surface, and our computer vision models were able to recognize them. So so what happens at Omdena is that when you apply to a project, and there's some people from the community and many people that are applying as new collaborators in a project, and it's super interesting. And if you'd like to talk about this more later on, now or at any other date, I'd be happy to talk to you guys about this. So coming towards the end of the presentation, why should you choose machine learning? So this is sort of talking about so I've seen a lot of people go into machine learning because it's cool, because it's one of the best fields to work in, but they don't really understand it, and their heart is not in the right place. So don't do machine learning for the sake of it. In any computer science problem, even if you do like machine learning, don't force it to any project. That is never good. That is a bad practice. So I want to talk to you guys about this. So I know there are only a few people in the meeting right now, but do you guys know what this model is that is there on the screen right now? If you don't, that's all right. That's completely okay. Okay, so this is a vision transformer, if you didn't know about it before. And this is, I'm so sorry. I'm so sorry. Okay, so this is a vision transformer, and it's actually my favorite neural network. A couple of months ago, I was really interested, I still am, in transformers. And one day I was just thinking, actually one night while I was about to go to sleep, I was just thinking, right now in computer vision, we use CNNs mostly, and now capsule networks too. So in CNNs, what happens is that the way CNN is different from a vanilla neural network is because it has the moving window algorithm. It goes over patches of images. Well, I was thinking the reason why many people have tried transformers or RNNs on images before hasn't worked out, because they were finding sequential relationship in an entire image all at once, which might not make sense because there might be localized sequential relationship in an image. So Vision Transformer comes ahead with a solution for that. But before I read this paper, this transformative paper that got accepted at ICLR last year, I thought about doing some experiments of my own with simple RNNs to really do interpretable analysis of why this makes sense. And it does. This paper proves it does make sense. So I'm still going to do experiments, because this paper doesn't really talk about the intrinsic behavior of transformers in images in localized patches and why it makes sense to do that. But it's something that anyone can take up on. So I'm sort of showing you so what looks like an interest in machine learning. And it comes with all its pros and cons. It's hard to read research papers. I'm not going to lie about it. It's hard for me. It's hard for most people that are in this field. Oh God. So it's hard for most people that are in this field, unless you're a veteran researcher. So it's hard to sometimes make sense of the charts that you're reading, trying to make sense of the table descriptions that you have, the figure descriptions that you have, or even equations. Sometimes it doesn't make sense. For example, if you're reading this for the first time, many of these things won't make sense, or even the second time or a third time. You might know MLP, the full form of MLP, multi-layer perceptron and layer normalization, but you might not know MSA. I do not know what MSA means in this part right now. I'm not saying I don't understand the paper, but you don't have to understand the entire paper always to understand what it means and what the authors are trying to do. And as you read more and more papers, you start to become better at reading more and more papers and reading them faster and making sense of them faster. So reading research papers is a big part of machine learning. So before getting in there, this is probably the biggest, part of machine learning. And be prepared to read a lot of papers, and it's fun and it's interesting and fascinating. I'm not saying it's not, but you need to know if how interested you are. So what I'm trying to say is, don't do machine learning for the sake of it, but choose machine learning because you find it inspiring. Ponder the big questions. It doesn't matter if you get it. Honestly doesn't matter if you get a big, high paying job in machine learning. It matters, but not as much as answering some of the fundamental questions that machine learning poses right now. That how can we go towards trying to get closer to how the human brain thinks. Boltzmann machines and restricted Boltzmann machines. Like, think about that more. Like, that's where deep learning specializations are so good, because apart from the technical material, Andrew also talks to a lot of heroes in machine learning at the end of each week. Andrew Karpathy, Jeffrey Hinton, Jan LeCun, and the founder of GAN, Ian Goodfellow. So sorry. So yeah, that was that. And just a quote that I always like to end with: just like neural networks, the key isn't success. It is to fail expensively and then learn from it to become better. So slowly, step by step, you'll make a lot of mistakes in everything that you do in machine learning, but everyone does, and you'll be able to become a lot better. So I believe that I'm way past my time that I thought I'd take. So yeah, this is the link that to this presentation. If you guys like to have it later on, Bitly ML Careers, and I would really appreciate some feedback about the presentation and what you guys would like to hear more. So if you go to this link, you can give me answers to just 3 questions, and if not, that's all right too. So I really hope you guys enjoyed the presentation, the workshop, and I'd be open to taking or questions now. So I'm going to stop sharing my screen to see some of the chat messages that I couldn't really see it. Open source Google Apps. That's a constant. So do you guys have any questions right now for me? And yeah, I know Michael has some questions. He said he has from the club. No questions.
I think it was you did like a very good job, by the way. I think maybe it was a lot. Maybe if you could like go through each of your individual points and like see if anyone has any questions for like each of those points.
Okay. So I don't know. Do you guys have any questions about how to make projects, for example, or how to get started in machine learning? Like, most people have questions about that. Like, how do you go from learning from online courses to applying to places? So sort of that transition, especially, was difficult for me when I was starting. So I don't know if you guys have any questions about that. But ask any questions. It doesn't matter. Where can I get help if I get stuck on something in my project? Very good question. I know. So first of all, you guys can talk to Michael at any point of time. He can help you out with any of your technical questions. But if it's more of a fundamental question, of always, you'd be surprised how many ML-related threats there are on Stack Overflow. For example, we were dealing with a lot of model stochasticity problems. Sometimes, machine learning models are so unpredictable that if you run them 100 times, you'll have 100 different results. So, but sometimes you don't want 100 different results. So we went online, and so you'll find places to look at are Stack Overflow, GitHub issues. GitHub issues are amazing. There's also GitHub discussions, a new feature on GitHub now, which is better to use. But right now, a lot of GitHub issues are already there that you can read from and understand from. Go through the materials again. Sometimes when there's a bug that you can't figure out, instead of a conceptual problem, go through your online course material again, and you'll figure out where your bug is, and debug it properly to make it work. Sometimes, most of the time, matrix multiplication is a big bug that sometimes people can't figure out when you have so many things going on. If it's more of a coding problem, like TensorFlow, that's why I don't like TensorFlow, because TensorFlow has so many bugs. If it's more of a TensorFlow problem, then go to TensorFlow's API online. and you'll find the documentation, and follow the documentation. Don't try. Well, if you try anything, it might not work, right? So, like, stick to the documentation, and those problems might disappear, hopefully. So that's what TensorFlow. I find TensorFlow funny. Um, sorry, I think I'm okay. Other questions, Michael? Do you have any questions?
I was gonna suggest maybe you could like get some water because you spoke a lot, but um, hmm. I think yeah, one question I've had because I've been doing like I've been looking at like a lot of Kaggle kernels trying to find like you know when I look at the kernels I see like the steps most people usually do, understand the data, visualize. Like how much visualization is like typically like do you typically need to do in order to like fully kind of understand the data to select a machine learning model?
Okay, that's a good question actually, and um, it's ad hoc and it depends per project. But I'd say that if it's a classification problem, or it's a computer vision problem, try to look at images. Try to look uh, at least a few images from each of the classes that you're classifying, and see if there's a good distribution of images. If it's an NLP problem, then look at word embeddings. So I don't know if if you guys want, there's this thing called TensorFlow Projector. I think it's called TensorFlow Projector. So if you go to TensorFlow Projector online, you can sort of just train basic embeddings and then plot those embeddings in a 3D space, and then analyze if some embeddings are grouped together. So with NLP, that could be an example of a visualization that you can do. With embeddings, because that's what you have in NLP. If it's a machine learning problem, right? So if it's a numerical and categorical variables all shuffled together, then what you can do is use Seaborn to see the correlation between the variables. That's also a good place to start, because the thing is, garbage in, garbage out. So if there's no correlation between your variables, you're trying to fit your model on you're trying to fit a model on patterns that don't exist. So in machine learning, you're trying to find patterns. If the patterns don't exist, it doesn't make sense to do modeling on it. But sometimes patterns might emerge if you drop some features. So that there comes in feature engineering. In classical machine learning, feature engineering takes a lot of time, takes more than a week and a half, which I said in the presentation. In classical machine learning engineering, you spend a couple of weeks trying to drop some features, combine some features. If you have categorical features, okay, so there's a, I don't know. So you see that chart over there on my wall. So like, I don't know, there's a paper over there on the wall. You can't read it, but there's a paper on there on the wall. That's a picture I took from an online Medium article that tells you 10 different ways you can have categorical features turned into numerical features. So you always need to see if it's an ordinal feature, if it's not ordinal, if it's cardinal, and how many different types of types there are. Like, you have 7 days in a week. So do you use one hot encoding, or do you use some other kind of encoding? So you decide, like, what kind of encoding do you want. And once you have all of those things, then you start with basic models, very small models, so that you can see if you're able to get good accuracy. If linear regression is doing 20%, then it's likely that your model is your data is not linear. There's no linear regression to there's no linear parameters to fit in the model. So it's ad hoc, and the most visualization that you'll ever do is in classical machine learning. If your problem isn't in classical machine learning, it makes sense to not do that much visualizations. Yeah, you shouldn't do any unnecessary things. So yeah, someone asked, Zindu asked, how to self-implement the algorithms for artificial neural network instead of using the library. I only know how to use the library. What is that right now? Oh, okay.
That's
So
right
you
now.
only know how to use the library right now. So okay, so what you can do is that use Python to do it step by step. Okay, let me try giving you guys a link. So yeah, so when you it's really important to make a neural network from scratch first because you get to learn back propagation, which is super important. And to be honest, my second favorite thing in machine learning, Jeffrey Hinton just the kill the field killed it when he made it like years ago, like many years ago. So yeah, okay. So find the MNIST data set and then make something like this. So this is one of the first repositories that I ever made in deep learning when I was doing the Coursera courses. When you do the Coursera courses, they teach you all of that, right? They give you do it for I think binary classification in computer vision, and you apply all the back propagation parts, and you do image processing a little bit here and there. So it's important to get the big picture. So you learn modular programming to get different Python files doing different things, one having activation functions, one doing back propagation, one doing the entire thing. Then when you put it all together, you'll face a lot of bugs because the back propagation for the last layer is different than the layers before, and especially the input layer doesn't have any back prop. So you'll face a lot of errors over there. But once you can figure that out, you won't face the errors when you do it in TensorFlow. And believe me, even if you're not facing them, you'll face them eventually. You'll find projects that will be just impossible to figure out that bug. And it's good to have this knowledge so that you can figure out that bug faster and in a more appropriate way, and not searching for basic things then now. So I hope that answers it. But take your time. You don't have to do it in one day. Take a week to make this kind of a project. And if you already know how to use high-level libraries, this should be easy for you.
Yeah, Ramansh, mind if I add something to your answer?
Yes, yeah. Go ahead.
Yeah, so it's I think yeah, it's kind of important to like kind of be able to kind of learn the self-implement the algorithms. I think if we had more time rather than just like weekly meetings, we'd probably be able to try to test out and like, efficiently kind of do the dot products and all the stuff and back propagations for it. Um, I think that in most of the club meetings we'll have in like the future when we talk about the neural networks, I'll try to like describe most of the math as like try so if you want to implement the algorithms for yourself, it would be kind of easy. Like you'd kind of understand what you need to do for it. Like, but for the sake of time, that's why I'm using stuff like TensorFlow and scikit-learn. But I think the self-implementing the algorithms would probably be helpful. And I think also
Oh,
that's why some people use PyTorch more than TensorFlow because PyTorch kind of gets more closer to the real math.
PyTorch is more Pythonic, and that's the best thing that I love about it, the Pythonic way, because you know how you have the model.fit function in TensorFlow? There's no fit function in PyTorch. PyTorch Lightning has it, but in a normal PyTorch, which most people use, you you form your own forward function. And when you form your own forward function, you can do so many more things than just call the fit function over there. And when you so it's important. So learn PyTorch too. If you're not learning it already, switch from TensorFlow to PyTorch as soon as you can because it's more useful in the industry. To be honest, I remember trying to find the algorithm for ANN and so on. Okay, how much time do you guys normally spend in your weekly meetings?
I try to push it as close to 60 minutes as possible.
Okay, so I think that 60 minutes, if you can prepare it beforehand, the kind of repository that I shared with you, it's possible to, I'm so sorry. Okay, so it's possible to prepare that kind of a repository and code base and then walk the students through it. So you can code it already or like have it aside and then you live code it so you can work through the matrix multiplications live. So I think working on an MNIST data set could be fast and like possible within 60 minutes, right? If you want to like think about it. You should do it in 1 hour a day if you have time. Okay. You guys have any other questions? I'd like it if you guys have any other, like career-wise questions too. Like, what do you think about it? Have I ever freelanced? Um, Once. So I worked for a Silicon Valley startup on behalf of Omdena. It wasn't really more of a freelance as a contractual job, and it was interesting. I learned a lot. Like how to work in the industry. Like to be honest, like a paid job, for example. and it was very interesting. But one mistake that I made was that I stopped learning everything else during the time of that project, and never make that mistake. I won't make that mistake again, and you should never make that mistake in the first place. There should be no single project in your daily life that should have all the importance. You should always have more than one things, and preferably more than two things going on at the same time. You can handle it, it's not unhandleable. I'm doing two big projects right now at the same time along with college, so it's not undoable. Take the pressure, it's fun, because once you take the pressure, when you get to places like IBM and Google Research or DeepMind or OpenMind, you'll find yourself at home there. So yeah, that's an extended answer to your question you asked, but yeah, you'll find more of these roles. Like in Omdena, they have this thing called talent projects. So once you contribute a lot to the community projects, the 2 month ones, for AI for good, for environmental and societal good, sometimes you're offered these talent projects to work still for AI for good projects, but more of private companies sort of. Okay. Are there any other questions? You can ask any questions whatsoever. Like what's it like in college? Uh, you know, Sometimes anything like related to computer science in general. For example, like one of the projects that I'm doing right now, apart from the one with WRI, is core computer science. So I'm working with so many APIs. One thing that I'd always advise is that learn how to use APIs as soon as you can and make them. Sometimes you host a lot of APIs, so you don't only use them, you make it for other people. REST APIs, of course. I don't know if there are any other API kinds are useful at all. So yeah, like it's called REST APIs. So um, yeah, like sometimes you won't always be working with machine learning. You'll sometimes work with web development, making your own personal website or your organization, or sometimes trying to upload your model onto web. Use Fast API. I used Flask for some time, but the next project that I need to host something on, I'd use Fast API. But like these things are for like people to use your models, like anyone you want to show it to. If another programmer needs to use your models, you do it through an API and you host it on Heroku. That's what I talked about in the presentation earlier. That like for example, I haven't hosted any models on Heroku yet for my own thing. I did it for another project once, but once you do, other people can call on an API and then get an output from your model through the web. So they won't have to run anything at all. That's what GPT-3 does. They give you an API. They don't, so you don't have to fine tune GPT-3. Well, you can, but it's not happening on your machine. So there's no heat coming out of your machine. So it's all happening on OpenAI's hardware. Okay. Any more questions? Okay, so Michael,
Yeah, I'm still here.
do you have any questions?
Well, we didn't get any questions from the rest of the members. We usually have like a lot more than these people who showed up. Um, I mean, it's you did like an amazing workshop. I didn't know a lot of the things like archive, archive. What was it like?
Sandy.
The archive sanity. That's probably going to be helpful. And yeah, I'll try to keep these things you said in mind. It's a long journey to kind of work through machine learning on my end. Like I'm trying to like learn like how to state the the inner depths of the algorithms with greater detail. But I think yeah, you've come a far way, and
Uh, the- so yeah, like that's what yeah, like I'm really glad that my workshop was useful to you guys. And what you just said is, in my opinion, the crux of um, learning machine learning and really moving through it. Because even the most experienced people I know, they learn on a daily basis more than they actually do their work. and that's what you do in this field. And I think I wrote an article some time ago. Let me share it. That Yeah, this one. Okay. So, basically, how can you be a happy data scientist? So, sometimes in this field, you'll feel a lot of imposter syndrome, and it's completely okay. Believe you cannot have felt more imposter syndrome than me. So, always know that you're not at as a bad position as bad a position as I have been on. And if you need to talk about it, I'm actually, I'm always available on LinkedIn or email. Anytime you guys want to talk. But yeah, this article that I just shared with you guys, um, I I and some other people from Omdena like detail some things you can keep in mind and practice so that you won't feel as much of an imposter syndrome because you'll be learning on a daily basis. Even now, um, on after one day, if I don't learn something new in machine learning, if I'm not following through something on PyTorch or in my modeling basis, I don't feel satisfied that much. And once you get to that point, instead of feeling that you're not learning enough, like try to reflect on the fact that you're not satisfied if you don't learn something new, and that in itself is an amazing thing to have. So you should get that eventually, if not now, if you're like starting out in this field. But sort of yeah, it's a long way to go anywhere, and you won't always be successful. Oh wait, okay. Deviating a little bit, have you ever used quantum algorithm with machine learning? No, I have not. Quantum machine learning is interesting, but I haven't really worked with it at all, and I don't really understand it even because I don't know how it really works. I'm like looking to actually get started with TinyML. I don't know if you guys have heard of TinyML. TinyML is something that like lives on your phone or like works on your phone and isn't does doesn't really use GPUs and TPUs to function. TinyML is big. TinyML is actually bigger than any other field right now because agriculture is a big place to use it in. Drones are a big place to use it in. So TinyML is an interesting field, not quantum. I don't think quantum ML is that broad or that intensive, but I have heard a lot about it. I don't know if Michael knows more about that. Okay, so yeah, I was just saying that you won't always be, you'll apply to a lot of places, and you might not always get in. So I don't get in all. I don't actually. I almost never get into the places I apply. I failed from technical like internship coding challenges from Google, Apple, Netflix, and I recently failed the Facebook AI interview. So if you don't get into your first page, just think about my failure track record, and you're that. Just don't hit it as low as me, and you'll be fine. Even if you hit lower than me, actually, I've seen other people shot right up once they start working hard. Yeah, everyone feels that, but once if you like true in your job, actually anywhere, and you just keep working and contributing as best as you can, that's what people want, and that's how it actually goes. So you won't be bad, like believe me, like even if you're hired, because recruiters won't hire you unless they're sure you can do well. So if you're there, just know that you deserve to be there, and once you start working, you'll see that everyone around you, as experienced as they might seem, if you're working on a common project, you're at the same level as them. They might have previous experiences that they can draw insights from, but once you start looking at the same code, you start looking at the same problems and you start trying to find answers at the same time. So I'm working with researchers from IBM right now in the same project that I'm working on, and we're working on the same things. So we're working on a library that did not have a function, so we are trying to implement it ourselves. So having fun with that. It doesn't matter, and the best thing is age doesn't matter at all in this field. So I have been working with, as I said, people who've been in this field for many years, not just this, but like computer science field. And I have been working with people younger than me. So 17 years is one of the youngest collaborators that I've ever had. If you work hard and you learn something in machine learning well, apply to Omdena, and you can be the next youngest collaborator. And it's fun to be like that, you know. Uh, and and if you do well, you might get connected to more opportunities. So apart from talent project, I see all the time people getting computer vision jobs through the Omdana community, and that's why communities are so good. Instead of just applying and finding things all by yourself, try to join some of the communities that I mentioned earlier. That will help you connect with other people, gain more perspective, and by transit property, gain more opportunities. Wait, what do you mean? How complicated your project needs to be? Like to apply to places? To like apply to places, it doesn't have to be super complicated. It just has to show that you know what you did and you understand what you did. It could be for an internship, if you've already worked with TensorFlow and you can apply and you can make a good ANN from scratch in Python, but do something novel, do something slightly more interesting than other people have done, then it shows that you have mastery of your subject. You can talk about it. You should always be comfortable talking technical stuff about your code. And once you can do that, um, people will know that you'll be able to do well at your job. So so recruiters won't reject you if you're recruiters don't reject you because you're bad. They reject you because they're not sure that you'll be able to do well at the intensive application or a position that you're applying for. So try to think of it that way. Um, where do you get the ideas for your project? Right when I'm about to go to sleep. So sometimes I have to write them down. But how do I get more ideas? I read about more things. So I actually think of AI in a lot of philosophical manner, like how we really think about it from a fundamental perspective, like really thinking more about gradient descent, and is it really how human brains think? So you can like in order to get more ideas, I'd say read more research papers. The literacy world in machine learning is just amazing. There's a lot of papers that just work on changing one small hyperparameter to get 0.01% better accuracy, and they go there. We've made new state of the art model. Those are not the best papers. The best papers are the ones that Jeremy Howard, the founder of Fast AI, teaches you to write, like for free on his online courses. Go to like fast.ai and you'll find what I'm talking about. Um, okay, I don't know what's going on. So when you read more research papers, you'll automatically think about things in a more broad perspective. Always think about going. I always say that when I become one small bit wiser, I have become one dimension. I've gained a dimension of perspective. So try to think the bigger picture. And when you think you know the bigger picture, try to find the bigger picture after that. Once you know, once you like zone out, you just look anywhere out in so many different things, so many different algorithms, pick any place, and you'll be able to work in it. It doesn't matter how inexperienced you are. If you can work out the math a little bit and like try to figure out a way to make the machine learning model work a little bit, you'll be able to write a good paper and even accept and have them be accepted at conferences. I've seen that happen. You can do that. Do you suffer from the curse of dimensionality? Yeah, I do. I totally do. I lose sometimes. I lose. I get so many big pictures that I lose. Track of the small picture. Like drinking water, or eating at the right time. So don't let that happen to you. So I by the way, like I go to sleep at 11:30. My parents think that's it's still too late, but you don't need to stay awake till 3 a.m. to be good, despite what people think. Just don't procrastinate too much, and you'll be fine. Okay, I don't know if we should still be recording this. Am I still answering questions? But um, I think that was good. There was a good workshop, and um, Yep. I started from this place, the Andrewing course, and Andrewing is the best teacher in the entire world, in my opinion. And 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 then it's like Andrewing and then Mischief. Mischief is my favorite teacher at Bronx. I don't know how many of you have Mischief at Bronx Science. How many of you have Mischief at Bronx Science? No? Ah, okay. So yeah, so like he teaches it really well, and that's why the machine learning course from Stanford is so good, and the deep learning specialization from deep learning AI is so good. There are other instructors that do it well. The NLP specialization is good because it's taught directly with deep learning AI. Deep learning AI has another specialization, the TensorFlow specialization. I found it okay because it just jumped directly into code. There wasn't really any insight about it, and that's probably because it was TensorFlow. But um, check out the specializations from deep learning. Yeah, I'm planning to take the medical, no, sorry, the medical computer vision one, or the medical like medicine specialization in deep learning from deep learning AI. And there's GAN specialization. And by the way, all these courses you can get them for free. I don't pay. They are paid, but apply for financial aid. And in exactly 15 days, you'll get them for free. I've told tens of people this. I've tried it on more than 20 paid courses myself, and it works every single time. You just answer two questions for 150 words, and in exactly 15 days, you get the course for free. You complete the course, you have the certificate for free. Certificates don't matter that much in this field anymore. So put them on your LinkedIn, but don't send them to recruiters. They don't hold any weight. Send code, send your GitHub repository. That holds weight. That holds weight. That holds weight. Yeah, that's more useful to see. So yeah, if you and I was just going to say that in the future, if you guys would like to have a discussion again, I'd be more than happy to take you to a more technical discussion. Probably, Michael, if you would like me to go through, for example, my digital recognizer project, I can walk you through it, like on another day, another time, to go sort of build an ANN through scratch. I think that could be a fun thing to do for the entire club, and I want to talk to the entire club next time. So I don't know. Let's find a common time for that. And I, even if it's a couple of hours after the time we started today, that's fine.